last class we had this different how to apply by class, how to aggregate function, how to write nested. So this just will discuss about joins. So joins means joins the operation combines the data from two or more table based on a common field, right. Joins is going to join or more table or two or more, but there must exist a logical relation. Say this is going to join on the common the data that is present the both of the. So we have in the SQL we have different joins, say inner join, we have inner join, left join, right join, natural join. These are the different joins. Yes. Then what is inner join? So inner join, default type of join in a join table. The default join that we use SQL. This inner join tuple is included in the result only if the matching tuple exists in the other. Inner join works on two table, say for example, say table 1 join say. So now this inner join compares the data from the field T1 with the data that is present in D2 on some field. If both are placed, say for example, if the T1 contains some field and the data is 1, and so in the T2 also there exists a data called 1, it is if both of the data are matching, only the corresponding records will be read. Respective data, suppose say 2 and say assume that this data is not matching with the record will not be getting. Means inner join compares the result the data from 1 to the data of second table. If both are matched, then the respective records will be. That is the function. For example, the select student course, the course ID, student name, and the age of the student from say student table. There is a student table and say there is a course table. There are two tables. There are tables, student and course. So means from where you are getting the data? You are getting the data from multiple tables, student 1 and say student 2. Okay. On is a keyword. So inner join, right? Inner join table, the join with the second table, on which field that you want to make a join, on which field that you want to make a join. So now in student table there is a field called roll number. Join this roll number of student with the student course dot roll number. This roll number present in another table called student course. Is both are common. The roll number of the roll number present are common, right. So now it is going to compare the value of this field. Then if there is a match, only include records. So that is the function of join. The function. So now see, look at here. Say if you apply the course student and say this is the course, right? This is the course table, the student course table, and this is the say course, the student table. Now say roll number is present here. Now, if you apply inner join, roll number present here, roll number is also present. Student course, student course table, course table, student table, student table. Now join, make a join, and that should be inner join. On which field that you want to join? This, right? This is I want to join down this of this table and this. Now, then compare the data of this, the data, this and this, and if there exist only such record. By looking at this, 1, 2, 3, 4, 5 is present here, and 1, 2, 3, 1, 2, 4, 5, and 9 is present. Right here, how many? 1, 2, 3, 4, 5. Here, 1, 2, 3, 4, 5, and 9. Now, if you look at this, so it is the course ID of such, say 1, 2, 2, 1, 2, 2, 1, 2, 2. Okay, it will be called inner join. So now compare this value with value, this value with value, this value with the value. Now wherever the data is matched, what will be getting. So now left outer join. So join, left join is the method, they say is a left outer join. Every tuple in the left table must appear in the result. If no matching tuple, then null will be included. So that is the left out, means you have a left table. See, if you have a left table, assume that this is a left table and this is a right table. If you apply the table 1, you apply the left join, as I call left of the outer join, on set this table, set table 1 and set table 2, on which field? So this field and this. Then what is the output you get? Is that this try to include all the values from the left table and the matching value in the right table. Matching value in the right table. If there is no match, then null will be red. There are no match, null will be. Now, so look at this example. So when you apply left join, you get, say, this, and there are no records, then there are no matching records, then for this value then null will be. So this is the left, the corresponding course. If the corresponding course ID is not exist, then null will be. So vice versa of this is right join. So it is going to compare the right table with the left table, and it is going to put all the records from the right table and the matching record from the left table, and if there are no match, then null will be. Okay. There are no matching record found, then so the null value. The natural join. So natural joins are nothing but joins. Natural joins are nothing but joins that is similar to inner join, but it is default. But what do you do in the, say, inner join? We are going to specify the column from the left table, column from the right table, then we are performing joins, isn't it? But in the natural join, Implicitly it assumes that it is going to find out and compare the common attribute value name in the both of the tables. Creates a join on the base of the common attribute the table. There the inner join, the name of the column need not to be the same. Example, now say this is table 1 and say now say this is the attribute 1, the attribute, and this is attribute 1, attribute. Now it is implicit, as it is an assumption, the natural join assumes that, and it is try to join two table on the common field. Common fields are what? A and B, sorry, A and B. Now if you apply the natural join, so then what you do is join on the common field. So here, look at here, just you can here in the previous slide, so inner join, while using inner join, what we did is, so table 1 inner join, table 2 on, use this word, isn't it, on which field, say field 1, sorry, table 1, table 1, table 1, what we did is table 1 dot field 1 is equal to table 2 dot field. So this is how we had used the inner join, but here if you apply the natural join, so it is not to mention this, not to, just it directly connects and joins A and A, because the name of the column present in both of the tables is A and A, then it applies. So that is a natural join. So this is the order of execution. When you write in any SQL statement, this SQL engine is going to follow this order. Always you need to write, select class first, then mention the attribute, the or say called the field names, right, from the table. So from class, next is from class, how to specify the tables, what are the different, or it may be from multiple tables. Then always specify where class, then specify group by class, then having, then order by, the order that you need to follow while writing. You cannot write why they were before, no, having here, group by here. Always you follow rule, select, from, where, group by, having, order by. There are 3 SQL commands to modify the database, that is say insert, delete and update, already as we discussed. Right. So it's about the the SQL, right, different ways of writing different mechanisms that you are going to get the data from the. Next is say views. Views are nothing but virtual tables, or say, right, the virtual. The concept of view in the SQL is single data table derived from the other tables is called defining table, or called virtual table. Views are considered to be a virtual table. So means that result can combine from more than one table and you can make a temporary table. These are nothing but temporary table. This temporary table, as a called virtual table, gets the data from multiple tables, and forms one single. Then you can apply the similar the way you apply, or the way you perform operation on this table, can perform the same type of operation on the views. That is nothing but the resultant table or the virtual table, right. You can perform or you can apply all the SQL operation, whatever the SQL operation that you perform, you can perform on also or nothing but virtual table. Now, virtual tables are the table gets the data from multiple tables and create one single table, then applies the SQL state on this. So, that is view. Views can be created. Views can be created by using a command called view. Get view. The command is give the table name, list of the attribute names, and the query to specify the content of the view. Now, you are going to specify the content what supposed to be there in view. Then how do you do that? You have to specify the name of the table, from which table that you want to fetch the data. What are the different attributes that you want to refer or that you want to get the data, from which that you want to get the data, and the query that you are going to write query to get the data from the this table of the attribute. So now let us say in view 1 attributes retain the names from the base tables, and in view 2, so attributes are assigning is the whatever the columns are the attributes that you specify in view can be renamed, or you can get the same name as present in the table. So that is what. Say, look at here the create view statement, the command that you are used to create a view called works on. The works on. This is the temporary table or called virtual table. What is the name of the virtual table? Is works on. Now, from where you are getting the data? As select. How to write? Get view works on as. From where you want to get the data? This query is going to return the data. From which table? That this employee table and the project table. Table. Here we are getting the data from 3 tables. From 3 tables, what are the names that you are, what are the fields that you are including? First name, last name, project name, the hours. These are the data that you are getting from the all the 3 wherever these data are matching. Now that will be pushed to a table. Sorry, what is that? View. What is that view? Is works on. Now works on contains what? Name, then last name, like this. The temporary first name, last name, and this is the what is that? And say what is that? Hours. What you get it in, right? What this is how your virtual table is. From where you are getting this virtual table? You are getting from the query. The query returning the values from table, this table as first name, last name, hours. Now virtual works on. This, so this is works on is the view, right? Works on is a. So now this contains some records called virtual table. This virtual table will get it from multiple tables relations. Are tables. To select some of the fields from this table, some of the fields from this table, are all the. Now is the views are formed from multiple, can have a selected the field name. This is another one. We are creating another view called department underscore info, where it contains department name, number of employees, and the total salary. So here the name, whatever the name of the fields which are coming from this query, the same will be there in your view. But here you can give your own name or the own field name to the fields that is present in. So now I am not using the same name, the same name of the field as written by the query, but I will give different name. I give different name. Then what you can do is the name of the view, just specify the name that you wish to include as a part of. Now select D name. Now D name will be as department name, count of star will be as number of employees, and the salary, sum of the salary as a total salary. Means in the view what you get is the table names in the view are a department name, then say next is a number of employees then say salary. Okay. How it looks for view when you apply column name. Otherwise, whatever the columns is there as say D name, count of stars, sum, it will appear as it is. So once view is defined, SQL queries can use the view relation in the from class. So the similar way you use for getting the data from the tables, can execute those queries on view as well. View is always up to date. Always up to date means whatever the data which is present in the table and the data present in view is always then responsibility of the DBMS and not the user, means making this view up to date. The data present in the table and the data present in the view must be same. Then whose responsibility is that? The DBMS take care of updating the views by getting the data from the table. So drop view command are used to dispose, means to remove the table, the view from the database. One of the database object, like when you don't want tables to be present in your database, what do? We use drop command, right? Drop table name. So that is going to remove the table from the database. The similar way, if you wanted to remove the view from the table, then we are going to use drop. So the different ways of implementing. The complex problem of efficiently implementing a view for a query means when you can, with the help of view, what you can do is you can resolve the complex problems. You can solve the complex problems. So now to do so, we have different strategies for implementing and updating and inlining. What are those? Query modification approach. The queries modification approach, compute the view as and when needed, do not store permanently. When you are using views or when you are implementing views, make sure that that view do not exist in the database permanently. So just use and say modify the view query into the query on underlying base table. Modify the view will be modified by the query that you are returned to get the data from the real. The drawback of this using view are insufficient for views defined via complex queries that are time consuming, right? So when you have millions of record and if you have not returned the query properly, sometimes due to some reason, maybe due to network problem or the without writing the queries efficient, the amount of time taken by the queries, right, it may be more, or sometime it may go to infinite, right. The query may enter into infinite loop, isn't it? Such case very difficult to use, means the views consume more time than the result. Because such case what you can do is to avoid the complex queries, writing complex query be avoided while creating a. Then the second strategy is that view can be materialized, right? Materialized. So what does that mean? Physically create a temporary view table when view first is queried, right? Now the query updation is what? It is going to create a temporary table, and say the table will disappear after the execution of query is over. But I want, what I can do is I want to retain this table, resultant table, given the query execution of the query execution gets over. So that is called view materialization, means it is something like storing the view, I mean sorry, temporary table in as a part of cache, and refer the data which is present in cache frequently. What I am saying? What does the cache do? Data which is be referred frequently will be stored in cache memory. Similarly, say what does the the view does is going to create a temporary memory, the temporary table, right? Right, as a called virtual table from this real tables. This virtual table will disappear as soon as the query gets over. This over, but I want to place this such a way that whenever I want to refer this data in future again we have to write the query and how to execute it, then populate this, then refer. But I don't want that to happen. So result should I store it in some portion, say cache memory, right? I want to store, I'll store cache memory. Now what I do is whenever I refer this result, I don't want, I'll not execute the query, get the data from this. I'll just refer this and get it. So that is called metal. Physically create a temporary view table when view is first queried. We are going to create a temporary table when we are writing a queries to get the data from this and place this portion as a part of cache. Keep the table on the assumption that the other queries on the view will follow the similar way, so that you use in the normal view. So you can use write a queries to get the data from. Requires efficient strategy for automatically updating the view table when the base table are updated. When you are using this strategy, materialization strategy, now we need to have a mechanism when that what does that mechanism will do is that as soon as the base table is updated, you must have a mechanism to update this table. That's so there is a delay, then the content of this may vary with the content of base table, so that is one of the drawback. Now how to do? Two disadvantages: performance degradation, right? Performance degradation, because you only create appearance of a table, not a real table, and the query process must translate the queries against the view in the queries against. Whatever the queries that we are going to use to get the data from the real table must be must perform on the getting the data. So that may degrade, say as I said, when queries are taking the longer time to get the result from the real table, then that will degrade the performance. So next is say triggers, right? So another topic in so triggers. The triggers are a procedure that is automatically invoked by DBMS. Thus procedure, set of SQL statement. Procedure is what? In say C program, what do? You write a set of key state. The similar way you can also perform, or you can also write a program like SQL statement that including loops and other the controls, right? The way you use program or other any programming language. You can also write the same the similar the procedures in the SQL. Now the triggers are the procedure that is automatically invoked by DBMS on changing in the database. As I said, can apply changes to the database, like while performing delete or while performing updation, the database will change the state. When the database changes the state, while insert, update or delete, I want to perform some operation. That operation is not been executed by the user, it should happen automatically, right? It should happen automatically. It should execute on its own, right? It should execute on own. Say for example, I want to download some files from the server which is there in US. I cannot keep keep downloading the data every day 24 hours. I'll write a procedure. That procedure, what does it will do is that will trigger as soon as the fellow who uploads the files on the US server. So this trigger will execute and downloads the file, right? So that procedure, that mechanism will perform automatically. So in such case, we are going to use the objective is to monitor the database and take initiate action when a condition occurs, when some operation occurs or say the event occurs. So against that event, a set of procedure will be get executed to perform the operation. Triggers are expressed in a syntax similar to the assertion and include the following. Means the triggers has got this structure: the events, condition and the action. So these are three which are associated well when you create a trigger. So this trigger consists of this event such as insert, delete and update. Means so you can, so these are the events that you can specify that will become part of event. The condition, so it means it is a test that returns when trigger is activated, right? So you can specify some condition or some SQL statement to perform some testing when certain event occurs, So this will be compared, means test will be the conditions that you are going to specify in test, tested or verified, right? Then actions will be taken place, then perform certain operations. So where you do that? So what action to be taken place based on this condition? If suppose if it is a true, in case if the condition is true, then what action need to be? So where you specify as a part of the SQL statement will create a trigger in the student database in which whenever the subject marks, example, okay, whenever subject marks are entered, so assume that there is a student table. I just that table consists of some columns for entering marks for the subject. Before inserting this data into the database, so see, so when you insert the database, sorry, when you insert any data to a database, before it stores into the database, some operation has to perform in between insertion and before storing. Before store, I want to perform some operation. That operation should happen automatically. For example, this is the database. The database. The database. database of some. Now we perform some entry marks, right? Assume that I am entering some marks, marks 1, marks 2, and it goes to some table and store permanent. But I want to perform some operation in between. Before you store the data into the database, I just perform some operation and I'll store along with that modified value. Okay. Then how to do? So we write a trigger. Please perform this operation. As soon as master is entered, do some operation, check for some condition. The condition is true, do some operation, then update into, then update it. That is what SQL statement say will create a trigger. SQL statement is going to create a trigger in the student database, right? In the database in which whenever subjects marks are entered, in the some marks are entered, before inserting this data into the database permanently, the trigger will compute those two values. Assume that say marks 1 and say marks 2. Assume that you are entering marks 1 and marks 2. Now we will write a trigger. What does it will do is it performs some computation, those two values, and insert them with the entered values. Insert them with the entered values. Perform. And so now how to create a trigger? Create trigger. This is the student marks. This is name of the trigger. Then next is what? Before insert on student, means before inserting the data into the student table, what you have to do is for each row, whatever the row that you wanted to update, or that whatever the marks that you wanted to store in your student table, set new dot total, right? Set new, there is a one column, right? Set one column called total in the student table. That total need to be computed automatically after entering the marks. That you need not to do, and that you need not to update again and again. So now what I do is I will enter this marks 1 and marks 2 and write a trigger. Whenever new marks are entered, I will write a trigger. What does the trigger do is that it is going to compute, say M1 plus M. Then it is to update the total as a part of total. Now after computing, what does it do is it is going to enter M1, M2 along with the total marks. So that is the operation. Now new dot total is equal to new dot subject 1. So whatever the new values, that plus subject 2 plus subject 3 and goes. Then percentage. So there is one more column called percentage. So update this percentage as well, just divided by. So this is means want to perform this operation, do some operation when the new marks are entered, or when the records about the marks are created. The record, when you are trying to enter the marks to create a record. So before storing into the database, perform some operation. What is that operation? You perform total and the percentage. Find out the percentage. Then update those two columns. Total, the name of the columns are total and the percentage, along with the marks 1. Along with marks 1. That is called trigger. Trigger to compare the employee's salary to his or supervisor. This is another the trigger that performs some operations, like say it is going to update the supervisor as soon as a new employee's mark, the salary is more than the employees who is already working. So before, so create trigger, inform supervisor. This is the name of the supervisor, to just give an alert to the supervisor saying that your salary is greater than the new entered salary. Before insert or update of. For inserting a record or updating a record into the salary and the supervisor. So, what you have to do is you have to perform this operation. For each row, for every row, when NUDA salary, the whatever the salary that you are entering, greater than the salary of the supervisor, that is more, right? That is more, then trigger, send a message saying that so the new salary entered is more than the salary that you earn. So that is the function of set. So drawbacks of triggers are difficult to locate unless you have proper documentation, because they are invisible to the client. This is one of the drawback. So this has been tied up to the object. This is a one object is been part of a database, but is not visible to the clients. So when you are performing proper, or when you are developing a application, so it is the responsibility of a developer to make a note of, or to documented the number of triggers that is the created, and which triggers refers to other trigger. Otherwise, it is very difficult to trace. If there are many nested triggers, if nested trigger in the sense one trigger can have other trigger which perform certain operations, that trigger may in turn has got one more trigger, and so that may goes to recursion. So there it may go to recursion. So there is a recursion, then so it is very difficult to find out triggering performing what operation on which. That's why very careful while using a trigger. So next is say the cursors. Cursors are say so now whenever you want to perform a row wise operation. So now as we know that the row is the table consists of set of rows of the rows, right, as a called tuple. I want to perform a row wise operation, right, instead of performing operation on complete rows or a set of rows, right, then we go for cursor. Cursor is a database object, retrieves the data from a relation one row at a time. When you apply a cursor on the relation, it is not include, say for example, select star from table. What does it will do? It's going to return all the records. It's going to return all the records from the table. Suppose if there are 10 records, all the 10 records will be returned. But to apply a cursor to a table, then not include all the 10 records at a time, but one record at a time. Apply the cursor, get the first record, then go to the next record, fetch it, then move to the next record, fetch it. So it means perform row by row operation. First it will finds this record or this row. Once it is returned, once the operation is performed, then fetch the next record, I mean say the row, then assigns these values of this the cursor, then move to the next row as a called next tuple, and it goes until it finds last record. Is the main reason to use cursors are to perform row by row operation instead of performing operation on set of the columns written at once. So this is the a life cycle as I call the way of creating a cursor. Declare a cursor. First you need a cursor, then open a cursor. Once the cursor is declared, you have to open to get the data from the table and perform operation. Next, the cursor is opened, fetch cursor. So now cursor is going to point out to the first it will point here, then when the cursor is fetched, point out to the first row, get the data of first row, and they store into some variables or whatever the operation that you want to perform. So, next is once data is fetched, then close it, close the cursor and then reallocate it. Now, first always you have to what you have to do is you have to declare a cursor, then open the cursor, then fetch the data, then close the cursor, then allocate it. So, this is how you can use the cursor. Declare student information, this is the name of the cursor, the name of the cursor. Okay, for which that you are defining the query, I mean sorry, the cursor for, right, for this. It is going to return set of records, right, and say point out by this. Then say we are opening cursor student info, then we are getting the data from student info. You see the variables. So, from this cursor we are storing the data, the student name into yes name and the then we are going to close cursor. So, means what is this returns a row, then we are going to perform a row by row operation by storing the values from this cursor into. Then what are the uses of cursor? The cursor allows us to process the data row by row, can be useful when we need to perform complex calculations or transformation on the data. Want to, as I said, want to perform couple operations one by one, then we are going to use the cursor. The cursor allows us to perform operations such as updating and inserting records based on some condition, right. So, cursors are specially useful when processing data from multiple tables where the relations are not. There are some scenarios where you cannot, there is no direct relations exist. So, now data you have to get the data from one independent table, getting the data from another independent table, then you perform the calculation. In such case, so you cannot perform on set of rows, but instead you get the single record, I'll say single row from one table, the another row from the another table, then perform the operation, then some other. Then what are the drawbacks of cursor? In processing data, imposes locks on the subset of a subset or entire table. For you are using cursor, lock complete table so that you cannot perform any other operation like insert, update, and the cursor update table records one row at a time, slow down the performance. Means because since you have to apply the the operations one row at a time, but applying operation one row at a time go down our the performance, right. While loops are slower than the cursors have more overhead. While loops are slower than the cursor. So, what does the while loop do is get the data from, going to loop on one record at a time, right, but it is slow as compared to. So, these are the different tables that we that we used examples, the example for employee table, where employee table has got first name, last name, date of birth and other stuff. Department table works on the dependent and so this is a company database, right, the company database, and say it is the that has been taken as an example to write a query, right,